It was rigged. This is how we used to drink for free at bars.
How many different ways can a football team score 9 points? What about 14 points? And how did I win these 5 beers? And what the heck do these coins have to do with any of this? There are different ways to think through the answer to this question. I challenged people in this bar to a race to see who could answer the fastest, but I had a trick up my sleeve.
I'm gonna use my piece of paper here.
I've been a software engineer for over 10 years, and these are the kinds of things I think about. What you need is a well-defined set of steps to come up with an answer quickly. In computer science, we call this an algorithm. But not all algorithms are made equal. That's why I knew my method would win the races and these beers. In this video, we'll learn more about algorithms, why some are faster than others, and how these coins led me to the more efficient algorithm I used to pull it off. Let's get into it. Alright, so the games are about to start, and I'm gonna go pester some people about math. Wish me luck. What's your name, by the way?
Jack.
Jack? I'm Kapil. Nice to meet you.
Nice to meet you.
If a team scores 9 points, how do you think that they got that?
3 field goals.
I would say that they scored a touchdown. There was a penalty.
Touchdown and a safety.
The 2-point conversion moved from the 2-yard line to the 1-yard line. They missed the 2-point conversion.
Touchdown safety, yes, that's the
Touchdown
one.
safety.
So they're still at 6, and then they get a field goal.
So we got 2 different ways.
Yes.
In football, there are 5 different ways teams can score points. A touchdown can be 7, 8, or 6 points, depending on how many extra points they go for and if they make it. A field goal is worth 3 points, and the less common safety is worth 2. And that's all the football you need to know for this video.
Are there any other ways that a team could get 9 points?
Absolutely.
You could do a touchdown and a safety.
Hold on. 3 safeties and a field goal.
Yeah, technically
Yeah.
it can be done.
You can get 3 safeties and 1 field goal. That'd be incredibly rare.
Are we counting that 1-point thing?
And yes, technically it is possible for a team to score 1 point if they get a safety on an extra kick, but that's literally never happened in the NFL, so we're going to ignore it.
So there's 4 ways to get 9 points.
The answer is 4.
Yeah, there's 4 different ways they can do it. I'm gonna challenge you now. How many ways can you think of to get 14 points? What about 14 points?
Oh, we're running off math here. Okay.
Yeah, you can see where we're going here.
Yeah.
Try this yourself. You're probably doing the same intuitive algorithm that everybody else was doing.
You can do 7
7
safeties.
safeties.
7 safeties, common.
How many field goals and how many safeties could we get?
Most people keep the target score in mind and try different combinations of point values, trying to see if they add up exactly to that target score. After listing as many combinations as you can think of, you'll end up with a list of all the different ways you can reach that target score.
Let me just walk through them in the head. I don't want to play equations. 1 touchdown, missed extra point, and then 2 field goals will get you to 14.
This process works well for 9 points when there's only 4 different ways to get there. But even for something like 14, the number of possibilities goes up, and it gets much harder to keep everything straight in your head.
We said 3. No, you can't do 3 field goals. It has to be 4
Okay.
field goals and a safety.
I think we're what, like, that was, I
Dude,
kind of
we're at
lost track. We're at like
now or
7
something,
different
6
ways.
or
Yeah.
7. Yeah.
Yeah.
You get 2 touchdowns. You can
You're doing really good.
2 touchdowns and a 2-point conversion on one of them. Yeah, I can't think of anything.
Okay,
I think that's about it.
I think that, so we got to like 8 different ways, I think, right?
Yeah, 8.
Okay.
8.
I do have some code where I wrote this up and I figured out there are 11 ways a team can score 14 points.
I asked all of them to describe their thought process for coming up with all the combinations and figure out which ones work. They might start at the smallest 2-point safety and see how many they can build up.
There has to be a huge chunk towards the bottom. 2, 3,
Yep,
6,
yep.
7, and 8 are your scores that you can work with.
Or they might start with the biggest 7 or 8s, working their way back down.
So I'll always go mod 7 and then try to make it work, then mod 6, then mod 3, mod 2, mod 1. That's what I was trying to do, yeah.
Either way, there's some sort of consistent way of coming up with those combinations, and we will get more concrete about that in a second.
Do you want to play a little bit of a game? If you pick a number between like 15 and 30, that'll be our target score. We'll race to see who can come up with the number of ways a team can score that many points first.
Oh shit.
So I got a piece of paper for you to work out any scratch notes that you have.
To understand why this process is slow and how we can improve it, we need to get more precise about how we generate those combinations and when we know to stop. We need to define it as an algorithm. To do that, we are going to make some change. Yeah, that kind of change. For a certain set of coins, like these standard US denominations, how many different ways can we make change for a particular amount, like 76 cents? This is called the coin change problem, and it's the standard way it's taught in computer science. This problem comes up in ATMs and vending machines, which use the efficient algorithm to determine which coins to use when making your change. It turns out our question about football scores is exactly the same thing, and by mapping it back to this coin change problem, we can take advantage of all the thought that's already been put in. Perhaps you can already see what the parallel is.
2, 3,
Yep.
6,
Yep.
7, and 8 are your scores that you can work with.
Yeah, there's a lot of those.
We can treat each type of scoring play as its own coin, and try to make change for, that is, add up to, a certain target score. The coins just describe the amount of value we're allowed to add in one move, just like a scoring play tells you the amount of points you can add in one play. As it turns out, the way most people think through football scores is exactly the recursive solution to the coin change problem, and understanding that is our ticket to figuring out how we can do better.
I don't know if you want to make it interesting.
Yeah.
Loser buys a winner a beer. Does that sound good? All right. Well, sounds great. All right.
I'll buy you a beer to be in your video.
Here, I got a piece of paper
Got it.
and for you to work it out.
Let's say we're going for a target of 10 points. The recursive algorithm will describe precisely what's going on in our brains when we think through the answer. Effectively, we're exploring all the branching combinations of ways to score, evaluating each one, whether it works or not, and finally counting them up in the end. Listing out combinations in our head amounts to traversing this branching tree. Assuming we're starting at the smallest score and working up, at every level we'll first explore the 2-point branch. Starting at 0, we'll add 2 points to get 2. That's less than our target score, so we keep going until we finally get up to, hey, a target score of 10. We found a valid way to score 10 points, that is, 5 safeties. Now from there, let's backtrack one level and try the next branch, 3 points. 8 plus 3 equals 11, which exceeds our target score, so this is not a valid way to score 10 points. And same thing for the other branches, 6, 7, 8. Backtracking again, 6 plus 3 equals 9, and from there, if we try all branches, we'll find they all exceed our target score, so none of those are valid ways to score 10 points. We continue this pattern of backtracking, trying every branch, backtracking, trying every branch, etc., each time continuing until we hit or exceed our target score, backtracking all the way to 0, trying the next branch of 3, continuing the process, etc., etc., etc. This gives us a precise description of how we generate all those combinations, and finally at the end we count up all the branches where we hit our target score exactly. And that gives us our answer. The problem is, this algorithm gets really slow as the target score increases.
I don't think we got that one.
And the safety, did I do that?
Not only is it hard to keep track of everything in our brains, it turns out we're actually doing way more work than necessary. In this tree, you can see we hit an intermediate score of 6 at least 3 times, meaning these 3 branches are all duplicated. All the work we did in this branch is a complete waste of time because we already did it over here. You could maybe refer back to numbers you've already done, but as the target score grows, this tree grows exponentially, and it becomes really hard to tell if you've already seen a number.
See, the missed extra point and made extra point, and then can you make that up with a 2-point conversion? That was just throwing me off. Like, there's a lot of combinations to go there.
In this big tree, have we already seen 3? And that's where the dynamic programming algorithm will save us.
I'm gonna use my piece of paper here.
Okay, alright.
Just a piece of paper, don't worry about it.
Yeah, you ain't need to look too hard at that.
This algorithm avoids all that duplicated work. Instead, we use answers from smaller numbers to compute the answers for bigger numbers. Instead of building up from 0 multiple times, we're just building up once.
This is not a trick in this or anything.
No. I'm here for fun.
The idea is that for any score, for example 14, there are 5 different ways you can get there, depending on the last scoring play that got you there. To get to 14 points, perhaps the last scoring play was a safety, and you started with 12 previously. Or maybe it was a field goal and you started with 11. You could also previously have been at 8 points and scored 6, or 7 and scored 7, or started at 6 and then scored 8. So the number of ways to score 14 points is some combination of these 5 values. And here's how it works. 26? Alright. The number is 26.
19.
The number is 19.
We'll build up our answer in multiple passes, one for each type of scoring play. To start it all off, we'll fill out what we know at the start, which is not a lot. There's one way to score 0 points, which is to just not score anything, and as of now, 0 ways to score anything else. The first iteration is for a 2-point safety. Starting at the target score of 2, we'll use this handy-dandy measuring device to look back 2 squares, and whatever number is in here, we'll add it here. This signifies that the number of ways to score 2 points, with the safety being your last score, is the number of ways to score 0. And from there, we shift over 1 and continue the pattern. Take whatever number is in here and add it to this cell. In this case, there are 0 ways to get from a score of 1 to a score of 3, because there's no way to get to a score of 1 in the first place. We'll shift up again and take the number from here and add it here. And we'll continue this all the way up to our target score of 14.
We're gonna have a time limit. I feel like we could run this thing for a while.
We'll start over with our next pass for the 3-point field goal. Starting at 3, take whatever number is here and add it here. Shift over and repeat and continue the pattern all the way up to our target score.
Time limit is however long it takes us to get bored or for the next game to start.
We'll do another pass for a 6-point touchdown, then 7, then 8, and in this way, we'll build up our answer pass by pass until finally we do the last value and we're left with our answer right under the target score.
All right, I got my answer.
I'm still going.
This strategy is less intuitive, but it distills everything down into a simple set of rules you can do almost unthinkingly, instead of wading through all the branching possibilities and remembering what you've already done. And the speed difference is not even close. For every increase of 1 in the target score, our tree grows exponentially in size. While for dynamic programming, each addition to the target score means just a few more additions. All the work you did previously is not wasted. I coded up these algorithms, and for a target score of about 300, the recursive algorithm starts to take few seconds, longer than I want to wait. Meanwhile, the dynamic programming code can go all the way up to 30 million before it gets anywhere near as slow. That's more to do with the computer memory than it is the algorithm. And that's why I knew I was gonna win.
We're gonna impose a time limit anytime.
I'll be done after this one.
I like the spirit of competition here. You're like, I'm not getting the wrong answer. I'm going all the way. My answer is 47.
Holy sh! All right, I'm a bit off.
Just for time's sake. But I know there's more.
Do you want to guess?
19.
19? Ooh. I came up with 18. What's the answer? The answer is 47.
47. All right.
Yeah, if you want to see how it works, subscribe to my YouTube channel. And then when this video comes out, it will explain how it works. But I'll also tell you right now.
Is this my ticket to fame?
18 is... Wow, you were really close.
So now you too know how to define an algorithm and how the coin change problem helped us compute our answers the fastest.
It's like I successfully fleeced him out of a beer. This is all a ruse.
It was rigged.
And please, algorithm responsibly.
This is how we just drink for free at bars.
I made some pretty good friends today, so I'm gonna make it up to them by buying them around. It's funny, I don't know if anyone's actually used the coin change algorithm for actual coins, but that's how I learned it in school, so how much was it total for all 5? Okay. For more fun math and computer science content, check out this video and subscribe for more. Back to counting.